we are going to take a look at our first gas law in our gases unit, and this is called Boyle's law. Now, essentially, we're looking at the relationship between pressure and volume of a gas. Now, what you'll see in this diagram here is that a lower pressure is a greater volume. So if you either increase the volume, okay, you're going to result in a lower pressure. Okay, and essentially that lower pressure is due to less collisions of your gas molecules with each other, as well as the sides of the container holding the gas. So lower pressure is a greater volume. Okay, now higher pressure is a smaller volume. So if you decrease the volume, you have a greater amount of pressure. You have more collisions with each other, the molecules of the gas molecules with each other, as well as the gas molecules with the walls of the container. So again, if you have a small volume, it's a higher pressure, or if you have a higher pressure, it's usually it usually results in a smaller volume. So this is what we call an inverse relationship. As pressure decreases, volume increases. As pressure increases, volume decreases. So we have this inverse relationship, and let's take a look at what that looks like in terms of a mathematical representation. So Boyle's law again states that as the pressure on a gas increases, the volume of the gas decreases proportionally. Okay, that's provided that the temperature and chemical amount remain constant. So we have to have some level of consistency in our experiment to test either the volume or pressure, which the things that remain consistent or controlled is our temperature and chemical amount of our gas. Okay, and when we say chemical amount, we mean number of moles. So our mathematical expression is P1 times V1, or pressure 1 times volume 1, equals pressure 2 times volume 2. So this is our initial conditions, and this is our final conditions. And let's just jot that down here. So this is initial and final conditions. So as long as we have our final conditions matching up and our initial conditions matching up, it doesn't really matter if we put our final on our left side or our final on our right side. All that matters is that our pressure and volume for this condition matches up in a pair, and this pressure and volume matches up in a pair. I still like to put my initial conditions on the left and my final conditions on the right. Now let's take a look at an example of what this looks like and the types of questions that you might see or be asked. So, Boyle's law example. This says a 2-liter, I'm just going to go through and underline any key information as we go through. A 2-liter party balloon at 98 kilopascals is taken to the top of a mountain where the pressure is 75 kilopascals. Assume that the temperature and chemical amount of the gas remain the same. Use Boyle's law to determine the new volume. So anything that I've underlined in orange is our initial condition set. So our P1, our V1, and our P2, and our V2 is what we have to record. So our initial pressure is at 98 kilopascals, and our initial volume is at 2 liters. Our final pressure is at 75 kilopascals, and we are looking for our final volume. So if we have our formula, P1 V1 equals P2 V2, I'll have to rearrange this formula to solve for my second volume. Now, because I'm multiplying P2 times V2 on my side here, what I'm going to need to do is I'm going to need to divide my P2 out to cancel out those entities. Now, whatever I do on one side of my equation, I also have to do on my other. So what I'm resulting in is V2 equals P1 V1 divided by P2. So that's how I would rearrange this formula. Again, if I needed to solve for P2, I would divide by V2, and it would be a similar mathematical function. Now, in this case, solving for my second volume or my final volume, I'm just going to begin by plugging in my variables into my equation. So I have P1, which is 98 kilopascals, times my V1, which is 2 liters. And these are the correct units I should be dealing with, is kilopascals and liters. Those are my standard imperial units. And my second pressure is 75 kilopascals. Oops, kilopascals, there we go. So when I plug this into my calculator, I get 98 times 2 divided by 75 kilopascals. This gives me an answer of 613 or 61 liters. Now, we want to make sure that this number makes some logical sense. So when I'm looking at it, I know that Boyle's law is an inverse relationship, okay? And we record an inverse relationship as 1 over our values, okay? So we have an inverse relationship, or it's not a direct relationship, which means that as my pressure decreases, so I'm just going to jot this down, as pressure decreases, that means my volume should increase. So I expect that in this case, my pressure went from 98 to 75 kilopascals, my pressure decreased, my volume should increase. So when I look at my values, I started at 2 liters and I result in 2.61 liters, which is an increase in volume. So this number does make some logical sense, or it is consistent with what we know about Boyle's law. Now, once you go through this example, and you may want to look through a few more examples, I think that this math is fairly simple math. You're dealing with 4 variables, and it's quite simple to rearrange these formulas. So you may want to check out a few more examples in the textbook before you move on to an assignment. But I would also like you to watch this video, which I've linked into your workspace, with the Psi guys and how they demonstrate Boyle's law of ideal gases, and they show you how pressure and volume are affected in a gas, and they'll show you some real life examples of how this occurs. So once you watch this, you can move on to your next lesson. So good luck.